Hello, welcome back to my computer monitor. A little too close. Okay, so today we're going to be taking a look at some ancient Pascal programming for vintage Macintosh system software. So this particular Macintosh is a Macintosh LC. I'll show you the about here. Running system software 7.1. This is a little bit newer than Turbo Pascal would have run on originally, but it will still work on this particular computer. Turbo Pascal, the version that I'm using is Turbo Pascal 1.1 for the Macintosh, which was released in 1986. As you can see, this is from 1992, but it'll still work. Turbo Pascal is new enough to support color quick draw, so you can write color applications in it. But anyway, let's go over to here. So what I've done is I've created like a very basic demo application. It's even more basic than their basic demo application that Turbo Pascal comes with. So we'll just take a look at going through the code and seeing what programming for Macintosh was like in 1986 and for a few years after. So these are our two files, demo.r and demo1.r and demo1.pas. This is the resource file. And this is the actual program file, so we'll open this, take a look at it. And we can also, while we're here, open the resource file. So the Pascal file starts off like any Pascal file does with the program name. We've got some compiler directives here. These ones, I'm not 100% sure what they're for. This one is your resource link, so you need that to link to the resource file if you have one. This one is the file system type. So the way that the older Macintosh, like Macintosh file system and a hierarchical file system, and HFS Plus also, the way that they identified what types different files were is with two strings. So the first is the I think it's the creator, and the second is the type or something like that. Yeah, pretty sure this is the first one is the, or maybe it's the first one is the type, and the second one is the created. Anyway, any application needs this one for the first one. I'm pretty sure that's the type. The type is Apple, and this would be the owner. This one you set to your custom application. So this one you can customize to whatever application you're. So I'll just set it to DMO1 for Demo 1. And the reason you need this is, well, there's two reasons really. One, the icon is tied to this part. So if you set the type different in the resource file, then the icon won't show up properly on your application in the Finder. And another is if you have any files that you want to be assigned to your program, you need to have this in those files, and then when you double click on those files, it will open with your program. And also I'll also determine the icon type that Finder shows those files as. So this second part is used to, This second part is used to identify what type the owner, I think it's called the owner string. It's used to identify the owner of the file. So Demo1 owns the application, and then if we had like a text file that we wanted to open with Demo1, we could assign this Demo1 as the creator or owner in the Finder, and then when we double clicked on that file, it would open with this application. So that's what that's for. If you don't have any files you want to open with your program, like you don't have any files that you want to open by default with your program when they double clicked, and if you don't have an icon that you want to assign to your program in the Finder, then you really don't, I don't think you need this one at all. Anyway, so moving on, we've got our standard. These, I'm not sure if you need all of these. This one I know is for the debugger. Sane is a debugger. Like OS interface, toolbox interface, sprite package interface, input output, types, quick draw. Probably need pretty much all of these for basically any application. This one I'm not sure if you need, that's for the debugger, but anyway, these are our libraries that we're using. We've got some global variables, so this is anytime an event comes to our application, this is the variable for that. We've got the main window, which is the main window that we've created, and we've also got front window, which is the window, which pointing to whichever window happens to be in the foremost window. We've got some rectangles we can use. So this is going to be the rectangle for when we drag the window. So see here, when I drag a window, I have a rectangle moving around. So that's what this drag area is for. And then this is just a rectangle to contain our button. We've got a flag to know when our application is done running. This is our window record for our main window. This is a, I'm not exactly sure what type, like why we need this, but this is used in some event handling functions. The window peek. So there's peek for our main window. Got a menu handle for our inserting our menu into the menu bar. We've got a control handle for our button. We've got a dialog pointer for our about dialog, and again a peek for that too. Again, that's used for event handling. We'll get to that later. And then the screen port is just like the graphics handle for our application. So we'll just go down through some of our functions. So we've just got a clear window here, which all this does is it checks to make sure that the window that's being passed in is actually our window. And if it is, and it's in front, then we'll clear it. Otherwise, it'll just do nothing. Do desk accessory. So this is kind of where this gets interesting. So vintage system software for Macintosh and all the way up until they changed over to OS 10 or OS X, whatever you want to call it. Macintosh was cooperative multitasking. So that basically means that when you're running an application, whatever application is running has entire control over the whole system and has to yield control when it feels like to other applications or to the system. So in this case, this is do desk accessories. So this means that whenever someone clicks on something on the Apple menu, one of these desk accessories, our application actually has to handle that and launch that desk accessory. So that's not system done. We have to do that ourselves. So all that this does is gets the item that was clicked on the menu. You can see our comment up here based on the item number. So we're passing in the number of the item on the menu that was clicked, and then we'll get the item and the name, get the name from that, and then we'll just launch that desk accessory. So that's pretty simple, but it's just kind of an interesting look at the cooperative nature of the multitasking on these older systems. So this is handling if any menu is clicked. All this is going to do is see if our menu item, so we have one custom menu item in this application. We can take a look at that in the resource file. We have one custom menu item that we've added to the Apple menu. So I'm going to check and see if that was clicked, and if it is, it's going to create a new dialog for the about dialog and show that dialog, and then it's just going to show that dialog as modal until the OK is clicked. So that's pretty basic there. It's kind of a lot of code, I guess. I think that's more code than it takes in Windows to show a dialog, but then again, in Windows you have to create a dialog callback, which we're not doing here. This is basically the entire code to run the dialog because it's not doing a whole lot. And then if they click OK, then we'll just hide the dialog. And otherwise, just assume that's a desk accessory, so we'll do the desk accessory based on which menu item was clicked. And this highlight menu, I think all that does is, like when you, like it highlights the menu like that. Like the three flashes, I think that's all that does. So this is handle click. This is if a click actually occurred on our window. So we'll go through a little bit of this code, which is, and all the code that we're doing here is seeing if our button was clicked, and if so, launching the same about dialog that the menu launches. So this takes in the location of the click. So it takes in the location of the click and also the window which was clicked. So first we're going to check and see if the window which was clicked is the front window, and if it's not, we'll move that window to the front. And then we will, this is graphics handling stuff, so just, because if someone was using the port before us to draw something, so we'll just save that port and then set the port to our window so that we can draw on our window. And then we'll convert the location to local window coordinates. And then what we will do is we will find out which control the click actually occurred on, if any. So there's also something I want to point out here. When this says handle click, it's not a click in the traditional sense of like down and up. This gets called anytime there's a mouse down. And we have to figure out whether we should handle the event based on where the mouse was released. So when a mouse goes down, the first thing we're going to do is find which control the mouse went down on, and that's using this find and control method. So we pass in the location, the pointer, and this will pass back the control in the control variable, which was just a control handle, I believe. Yeah, so the control is just a control handle. So we'll get passed back in that. And if I is 0, then no control was hit, so we'll exit here. And the reason for this is because the next step is tracking the control. So if I click and then drag, that's the tracking. So if you just do this part and you don't track, then you're not sure that the user actually released the mouse button while still on top of your control. So if I say, for example, I had a button right here. Say this was a button. If I click here and then drag and then release, that is what this track control does. So this will tell you which control the mouse was released on. And if no control was clicked and you try and track a click on no control, bad things happen. Basically the entire system explodes. And I can show you that a little bit later. Another application. I'll show you that in the emulator so I don't have to reset this machine. But so first we need to find out which control was clicked, and then we need to find out and make sure that the mouse was released on top of that control. And if it was, then we check and see if the control which was both clicked and dragged is our button that we've made. And if it is, then we'll show the dialog, which we're using the same code that we did before. We'll just create a new dialog and then set the port to draw on that dialog and then show it, and then just wait until OK is clicked, and when OK is clicked, then we'll just hide it and then reset the port back to whatever the port was before we entered this function. So not super complicated, just some stuff to keep in mind is you have to do both find control and track control, and then handle the event based on what control the end result was. So this is if someone closes the window, and kind of the same idea here. If they clicked, so this is the go away box up here, the still close box. So if the go away box is clicked on the front window, then we'll get the peak for that window. So like I said, this window peak is used for event handling. And then again, we have to track the go away, so that means that if someone clicks on the go away but then drags off, we need to handle that ourselves with this track go away. And if they didn't drag off, then if the kind of window is user kind, which is our window has type user kind, which we set when we create the window, and then we'll just set our flag to finished equals true, and that will basically tell our program that we're done in the next event loop. And otherwise, if the window kind is not user kind, then we're going to assume that someone clicked the close button on desk accessory, so we have to close that desk accessory. So again, we have to handle the when a user clicks close on a desk accessory because the system's not handling that. We have to handle it ourselves. And if the go away box was clicked on a window which was not in front, just move that window to the front. And we're not going to close a window that was not in front when they clicked close, because that would just not how we do things. Because like if you see here, we don't see the go away icon here, but it's actually still there. So if I click like right here where the go away icon would be, it just brings the window to the front. we don't want to close that window, we just want to bring it to the front. So that's what that code does. And this is handle mouse down. So this is what will determine where the mouse was pressed and call the appropriate function. So I'm going to get so this is where the event is passed in. We're going to get the location of the mouse click and the window, and the window location. So the window location can be one of these options. So if someone clicked the menu bar, then we need to call our handle menu function, which we went through above. If someone clicked in the content of the window, we need to call the handle click function, which we just went through above. If someone clicked in the go away box, then we need to call our handle go away function, which we mentioned above. And if someone clicked in drag, then we need to handle. So this is a library provided function. We didn't write this. This is part of the library. This is handling dragging of the window. So if someone clicks on the title bar and drags the window, that's what this function handles. And then this one, so this is if someone clicks something inside a desk accessory, we have to tell that desk accessory that someone did something in it and make it handle its event. So basically we're telling the system that someone clicked in one of the system's windows and have the system handle that event. That's what this does. So some of the more weirdness of cooperative multitasking. We basically are telling the system that someone clicked in a system window. And if we left this out, then whenever you open the desk accessory, you wouldn't be able to do anything in it because no one would be telling the system that someone is clicking in the desk accessory. Which is interesting, but that's the way they did it. So this is just if the system tells us we need to update our window. If the window that they sent us is our window, then we'll just save the original graphics port, set the port to our window, and then begin update is letting the system know that we are beginning our update. Windows has a similar thing to this, I believe, as well. It's called like begin paint or begin draw or something, I think. Anyway, so we're just going to clear the window, which we mentioned above, and then draw the controls for our window, which is a system provided function, and then we're letting the system know that we finished our update, and then set the port back to the original graphics port that it was before we started. Now this is handle activate, so this is, I believe this is when our window gets pulled to the front. This gets called. So this is the event that's getting passed in. Not exactly sure what this A flag is for. This is something I just copied out of their examples, and I'm not 100% sure what this is for. So not a lot of comment I can give on this function. I'm not 100% sure what exactly it does. Like I said, I just copied this from their examples, but looks like this is setting, so if this A flag is true, then probably like an active flag or something, I'm guessing. If the window is active, then we're going to set the graphics port to our window and put it in the front. So we're setting the pointer for the front window equal to our window. Or I guess this is the window that's being passed in. Yeah, this is the window that's being passed in. So if the window is active, then we're marking our front pointer equal to the window which is now in front. I'm guessing this is if no window is active, then we'll set front window to nil. So probably there's a click on the desktop or something. And if the window that's being activated is our window, then draw the menu bar for our window. And then this handle event is where all the events come to. So it breaks out what the event is based on the type of it. So if the event is a mouse down event, then we'll call our handle mouse down function, which we did above. If it's an update event, then we'll call the handle update function, which we mentioned above. And if it's an activate event, then we'll call the handle activate function, which we just went through. And then down here is the initialization procedure. So this is going to initialize graphics. This is a constant. This is not our variable. This is something library provided. All of these functions are. So we're going to initialize graphics, fonts, windows, menus, text edit. This is, I believe this is for like the copy and paste controls, this text edit library. Initialize dialogues and clear the event queue. And then we're going to create the menu bar. So we're going to get the menu from our resources. we're going to add, I believe this is adding, so this menu from our resources only has the one item which we've created. So this is, I believe this is going to add our one menu item to the main menu. Yeah, and then insert it, and then draw the menu bar. And then here we are going to set the port to the screen and then create our window. So again, this is getting a window from the resource. So by the way, these numbers here are the resource IDs. So 1000 is the resource ID of the menu. So this is looking in the resource for a menu with ID 1000. This is looking in the resource for a window with ID 1000. The rect which we've declared in our global variables. I'll set the port to the newly created window, set the front window to our window, and then mark the window as user kind, which is what which is something that we're doing logic on based on our callback, to see whether the window that was clicked was a user kind, or if it's not, then it's probably a system window. So we set that flag here, and then this is setting up a region for, so this is setting up that rectangle that you see when we drag the window. So this is getting the screen area, and then we're going to set the drag area to 525, and then the right of the screen and the bottom of the screen, right of the screen -5, the bottom of the screen -10. So maybe I was mistaken earlier when I said that this rect is the box for the window. This might be the box for where you can drag the window, so that you can't drag the window, out of bounds. That's probably what that's for. So I might have made a mistake when I described that earlier. I believe that's what that's for. And then this is setting the rectangle to house our button. This is the top. This is the top, right, and left, or the top, the top, and then the left, and then the right and the bottom. Then we'll create a new control for our button with text go. This is the ID, and this is probably visibility, and I'm not sure what these are. I've never seen any variables passed in there but 0 in the other example, so I just passed in 0 in mine, and it works. You can probably find this information if you dig through the Macintosh, Macintosh toolbox, but inside Macintosh. There's a book called Inside Macintosh, which goes through a lot of the information. You can probably find it in there if you really need to know what this is for, but this works, so that's what I'm going with. We'll set the cursor to arrow, and then our finish flag, we're going to set that as false for now, which will be set true when the program is done. So cleanup down here, this is just going to get rid of the window, and then our main function down here, so we're going to init, and then we're going to let the system do any tasks it needs to do. So for example, if someone clicked on something in the disk accessory, or if we're waiting for an IO function to run, this will allow that to happen. And then we're going to get the next event from the event queue and pass it into handle event, and we're going to do that until the finish flag is set to true, and when it's set to true, then we'll just clean up and end. So this is another very important thing. If you don't have this in here, then the system won't be able to do anything while your program is running, because you didn't allow the system to do anything while your program is running. So another weirdness of cooperative multitasking. So let's move on to the resource file, which is not that. Wait to see my other windows. There we go. So this is our resource file for our program. This is just, I believe this is a string that's stored in the file system. Not 100% sure. But all the samples had that, so I added that in mine. This is some text. If we need a text resource, probably actually not using this, so I probably could delete that. But so this is the file ref. So this is again telling the system that our file is of type Apple, which means it's an executable. And then we have this binding here. I'm just going to bind the icon. So notice that, yeah, so we're going to bind demo1 to the icon with ID 1100, and also bind that to the file reference 1100, which is this file reference up here. So probably should go through what this is. So this is the, let me go through what these things actually mean. So the type tells what type of resource it is. In this case, it's a file reference resource. This is the resource ID, in this case 1100, and then this is the actual resource content. So like down here we have a type binding, I think this stands for binding, with ID of 1100, and the content is demo1, which is declared up here, so that's what we're using that. Demo1 is bound to icon of ID 1100 and file ref of ID 1100. So this file ref and this icon right here, ID 1100. So this is another fun part. Your icons, you have to store them in hex format. So this right here is the icon data, which I manually typed in hex format. And you'll see what that makes in a little bit when we build this. And then below is the mask. So this is the actual image of the icon, 1 bit per pixel, black and white. And then this is the mask, so that when you click on the icon in Finder and highlights the icon, you only want to highlight the areas of the icon that actually contain an image. So for example, if you have a circle, I can probably show this right here. So for example, when I click on this, see how the highlight applies to just the colored icon? It doesn't make a full square out of the highlight, versus if I click on this one, see how it makes the full square? So the mask on this one is not set correctly. The mask should have not included these 4 corners, because since it does include the 4 corners, and the highlight includes the 4 corners. So that's what that mask is for. That mask, if there's a 1, then the area should be highlighted. If there's a 0, then the area should not be highlighted, it should be transparent. So that's what this mask here is for. Again, 1 bit per pixel, either 1 for yes, including the icon, or 0 for no, transparent, not part of the icon. And then this is another icon. This is without a mask. This icon is what we use in the about dialog. So it's the same icon, it's just redefined without a mask for use in displaying in the about icon, or the about dialog rather. Here's our menu. It only contains one thing, which is about. And I believe this causes the bar to appear. So if you look, see they have the horizontal bar there. I believe that's what this does. No, I think the /14 might mean Apple. I'm not 100% sure on that, but I think that's what that's for. So now we're going to get into our window resources. So we've got the type window, ID 1000. So if you remember from our code, when we create the window, we're using ID 1000. So this is the window that we're loading when we create the window in our application. This is the title. These are the coordinates, and as you see, I've declared them up here. So top, left, and then bottom, and then right. Visible means the window is visible, and go away means it has this little go away box. You can also set this to no go away, and then it won't have the go away box. And these are the border styles. I'm not 100% sure what each of these does, but if you notice in our main window, we've got 0, 0. In our dialog, we've got 1, 1 for a dialog border. So for this is our dialog. Again, ID 1000. You can share IDs across different types. So I can have the same ID in window type and dialog type, and this is a dialog item list. As long as they're different types. Now, if I had 2 dialogs, I have to have different IDs for each dialog. But since these are different types, I can use the same ID because I'm using the function, a different function to load each one. I'm using the dialog function to load dialog by ID and the window function to load window by ID. So it doesn't matter if those IDs are the same. The function will distinguish. So again, dialog, title, coordinates, and then the dialog is invisible because we don't want it to show at startup, and it has no go away. And then the border types, and this is the dialog item list ID. So that's declared down here. Dialog item list ID 1000 is used in this dialog. And this is just a list of items for the dialog, again ID 1000, and then there are 4 items in the list, and those items follow below, and they are a button item, which is enabled, and it has those coordinates and text OK. A stat item, which is basically just like a text box, that's disabled because you don't want it to be editable, coordinates, and then the text for it, and an icon, which is disabled, the coordinates, and then the ID of the icon, which we defined above. This is the icon without the mask, that second icon we defined. And then stat item, another text area, disabled, and then some text. So that's basically all of the code and the resources that we need in order to have a functioning application. So before we can actually run this application, then we have to compile the resource file. So we will just close this out, and then we can switch back to here. And we need to open this program called RMaker, which will compile the resource file. Because if you notice in the Pascal file, the resource we included, I can probably show that. Maybe. Probably show that up here. The resource we included was demo1.rsrc, but the resource file which we had was demo1.r, so we need to compile it to this before we can continue. Let's just switch back to RMaker. Demo1.r, we'll open that, and we'll compile it. And it looks like it was successful. I got to the bottom of the file, so we can quit, and we should see that output here somewhere, hopefully. Not sure where it went. There it is, demo1.rsrc. So that's out there. So now we can go back to our Pascal program, and we can go to compile and say run. And it should launch the application, hopefully. Or not. Oh, that's interesting. If it ran out of memory or something. So let me see if I can get this unstuck, and we'll proceed from there. Okay, so let's try again. This time we'll try compiling it first and then running it. Maybe the system ran out of memory or something. So we'll do compile and to disk, and hopefully this will be successful. Looks like it was, so now we'll put out of here and see if we can run the application without exploding things. And you can see there's our application, and that's what that hex icon turned out to be. So let's see if we can open this now. There we go, now it's working. So apparently run is not working on Macintosh LC. I should have tried that ahead of time, but that's okay. It's working this way. So this is it. This is our application. We can drag it. Then hit the go button. And if we drag off the go button, nothing happens. If we hit the go button and stay on the go button, pops up our dialog, which is modal. So you can see we can't click outside of it. Just waiting for us to click the OK button, which we can say OK, and we can go back here, and then we are released from our modal. You have the Apple menu, so we can launch, say, puzzle. Got a little puzzle here, and still go back to our application. So again, we're handling, not necessarily handling, but directing all of the clicks. So anytime I click in here, we're telling the system that somebody clicked in here, and then the system has to handle it itself. Same thing here. So watch, if I click on the go away icon, it just brings the window to the front, it doesn't close it, and we showed that in the code. Same thing here, if I click on the go away icon, it just brings the window to the front. If I click on close, and then our program is getting that and closing the desk accessory. control about dialog, which is just the same dialog. You can see how the border here is different, that we defined that different border in our resource file, and that we defined the text and the icon and the OK button. So I think that is about it. And you can see if I drag on a non-control, it doesn't crash. If you close it, it'll close because you just set finish to true when the window is closed. Now this one, I think this one, when I wrote this a long time ago, I forgot to check and see if a control was clicked. So I think this one, if you drag on a non-control, okay, it just crashes. Yeah. Application unknown has unexpectedly quit. Yeah, so that's what happens if you try to drag on, if you try to track controls on a non-existing control, it just crashes. This is system 7, so this is crashing a bit nicer. Let me fire up an emulator and show you what happens in system 4. It's much more spectacular. This is not ideal, but it'll work. This is mini VMAC. It's running system 4, running exactly, don't know what version system 4, some version. So open up that same application here, if I can find it, and now I will try dragging on a non-existing control, and yeah. So definitely improved the error handling from system 4 to system 7, but just thought that was kind of funny. Such a simple mistake has such dire consequences. But anyway, I hope you enjoyed this look at some Pascal programming on vintage Macintoshes. Like I said, Turbo Pascal from 1986. So I have run it on my Macintosh Plus. I showed that a couple years ago in a video. It works on even up to system 7, and probably would even work on system 8 possibly. I think the applications generated by Turbo Pascal will work all the way back to like system 1, and I think they work up to system 8 or 9 as well, the compiled applications. So just thought that'd be an interesting thing to take a look at. Don't see cooperative multitasking very often. It's an interesting paradigm, but anyway, hope you enjoyed this video, and thank you for watching. And so to Steve Jobs, there is one more thing, well maybe more than one. Let's take a look at some of the demo applications that came with this thing, just for fun. There's a lot of cool demos they have here that are into some kind of, I don't want to say complicated, but cool things that you can do with Turbo Pascal. It's very full featured. Let's see if I can find, like this one. So this is the color interface. Should probably build these before running them since it doesn't like to run on here, so I'll just compile this to disk. And then what this does, this doesn't have an icon in the resource, so it just gets the default icon. It does some nice color graphics demos there. It shows you how to use the color interface, and you just click anywhere to exit. So you can also do, what else can we do here? Let's do noise. Let's see, where did it put it? Possibly this is it. If you can hear that, but it is actually playing music. There's no way to control the volume though, just the built-in speaker. So hopefully you can hear these, but that's just sounds like record scratches. It's kind of cool, shows you how to use the built-in speaker, and we'll also do this one. Just type in some text here.
Hello, I am Macintosh.
Not sure if you can hear it. Let me move you closer to the computer, see if you can hear it then. The speaker I think is in the top. I think it is. So see if you can hear it any better now. Starting with the chords. Do the same square wave demo. For the random. That's the random one, sounds like record scratches. Let's go to the sound one. Let's do Steve Jobs one you did on stage. There's a video on YouTube of Steve Jobs introducing the Macintosh, and when he introduced it and brought it up on stage, he was demonstrating the speech features. So we'll have this one say what he said, even though this is definitely a later model, but still kind of fun.
Hello, I am Macintoshes. It's great to get out of that bag.
So that's what Steve Jobs had to say when he introduced it. But anyway, some cool demos, and hope you enjoyed this look at the basics, the very basics of cooperative multitasking Pascal programming on these vintage Macintoshes. So hope you enjoyed this video, and thank you for watching.